Welcome to myprojectbazzar.com. The title of our project is Hardware Software Stitching Algorithm in Lightweight Q-Learning System on SoC chip for shortest path optimization. The abstract of our project is to present a novel hardware and software co-design approach to accelerate Q-learning algorithm using a RISC-V-based SoC design. We introduce a maze stitching algorithm that enables efficient solving of large complex mazes by decomposing them into a small submazes, and this can be performed by Q-learning computation in low complexity hardware acceleration. And furtherly, we provide a comprehensive analysis of algorithm complexity, theoretical performance gain, and practical implementation result. And the proposed implementation demonstrate significant performance improvements over traditional software approaches, and achieving speed of ranges from 84 cross to 233 cross for complex maze solving tasks while maintaining a small footprint. And this proposed system combines a 64-bit RISC-V code with a Q-learning accelerator operating at a 40 MHz on RTX A700 FPGA. And the main objective for choosing maze stitching techniques because it allows for scaling to larger problem sizes while maintaining hardware efficiency, and the proposed work can be applied to the lightweight accelerator and provides a scalable solution for resource constrained edge computing environments like which we have used in furtherly. And the main objective of our project is to implement stitching algorithm for hardware and software efficient and seamlessly integrate Q-learning capabilities with SoC architecture and optimize the shortest path finding its resource constrained environment and to reduce power consumption and memory footprint of Q-learning implementation. Now let's see the demo of our project. This is our overall flow of our project. Here we are going to design using RISC, and here we will be using two algorithms, stitching algorithm and Q-learning algorithm. Based on this, the coding will be executed. The language which we have used for designing is Verilog code. Now let's see that. This is our Xilinx Vivado screen, and here you can see the sources. This is our deployment code. This is our Verilog code, and we are going to run our test bench. After importing the sources and the files to the design sources and simulation sources, we will be initiating the simulation. After uploading the codes, the next step is simulation code where it results as a waveform. Let's see that. And here in the flow navigator you can see simulation. In that, give run simulation, give run behavior simulation. It will be loading. And the next step is elaboration and synthesis. Let's see that. Here we will be synthesizing RTL analysis, netlist generation, and technology mapping. Let's see that. This is our waveform analysis. And here in the flow navigator you can see our RTL analysis. Just click that, and here you will be opened as open elaborated design. Dialog box will be open to perform IO planning. Just click OK. And this is our IO planning and the overall FPGA device plan. You can see the structures, gates, ALUs here. This is our overall FPGA plan, and this is our IO, overall IO of our project. Yes, you can see the overall structure, and in console also it will be filtered. Then in the flow navigator, click schematic to view the overall schematic of the project. Here you can view the mux which we have used and the overall circuit which we have used here. Okay, this is our overall schematic diagram. And the next step of our project is implementation. Let's see that. The next step is synthesis. In the flow navigator, just click run synthesis, and this dialog box will be opened. Just click OK. And here the running synthesis design will be popped up. Once it's done, the dialog box will be opened. Once the synthesis is done, here you will get a pop-up message as successfully completed, and here you will be getting run implementation, because the next step of our project is implementation. Just here also we can give run implementation, or else you can go to follow navigator and click run in synthesis. Synthesis is completed and implementation is initiated. Here it might take some time. Let's wait. Once the implementation is done, this dialog box will be opened notifying that successfully completed. Just click open implemented design. And the device overall implementation circuit. And here will be analyzing the power report in implementation flow navigator. Click power report. This box will be opened. Give OK. And here we will be analyzing the overall power, 99% on chip, and total power on chip will be analyzed here. Thank you.